So this is mixed exercise of the further statistics of a level edexcel. The chapter 1, discrete random variables. So I will solve the questions of with this flag, like E, P, EP, something like. So number 4, discrete random variable x has probability function. So k equals 1/4. So let me compose the table with that. So the sample space is 0, 1, 2, 3. 0, 1, 2, 3. This is x and probability of x. When it equals 0, it is k, 1, 0, 2, k, 3, 2k. So until here. So this is the whole possible cases for this case. So because since this is sample space, all the probability when we add them together should be 1. Therefore, k equals 1/4. And the expectation is the sum of product of x and px. So 0 times k plus 1 times 0, 2 times k, 3 times 2k. We add them together. So 8k, therefore 2. And show that the square root of expectation of the squares. The squares is just real squares. 0, 1, 4, 9. So 0 times k, 1 times 0, 4 times k, 9 times 2k. So 22k, therefore 5.5. So variance. So since we know them, we can find the variance of x first. Variance of x is the expectation of squares minus squares of expectations. So 5.5 minus 2 squares, so 1.5. But what we want to know is this transformed data. So when we have like 2x minus 2, this affects the variance like a squared. So 2 squared times variance of x. So 2 squares times 1.5, which is 6. Number 8. So now given P and Q, when we add them together, again, P plus Q plus 0.3 plus 0.1 plus 0.1 should be 1. So 0.5. And when we add them together, 2P plus 3Q plus 0.1 plus 1.2, 0.5. This should be 3.1. So 2P plus 3Q becomes 1.8. So 1.3. So 2P plus 2Q becomes 1. So Q is 0.3. And P, when we add them together, 0.5. So P equals 0.2. So variance of x. So now here 0.2, 0.3. So 1, 4, 9, 16, 25. So again, expectation of squares minus squares of expectation. So squares, 1 times 0.1, 4 times 0.2, 9 times 0.3, 16 times 0.3, 25 times 0.1, minus 3.1 squares. So 0.1, 0.8, 2.7, which is 3.6, and 4.8, 4, 8.4, 2.5, 10.9, minus 3, 9.61. So 9 to 0.29. Oh no, 1.29. So this is variance of x. So variance of 2x is 2 squared times the variance of x. So times 4. 5.16, is it? Yep. So this is the answer. And number 9, value of k, expectation of the variance 2.02 show that. But this is too repetitive. Let me find the number 9, just explain you, and I'll just skip it. So again, we can compose a table like 1, 2, 3, 4, 5. And when we add them together, the probability, we need to get 1. Then you can find k. And you can sum up all together a product of x and probability. Then you will find exact value of e of x. And when you find expectation of x squared and minus squares of expectation, then you will get 2.02. And 1 decimal place variance of, even this is a negative, variance never have any negative. So, and even it is negative 2 squares is 4. So 2 squares, usually we call this a, like ax plus b, the transformed form, general form. Then the standard deviation get effect of the modulus of a. And variance is modulus of a squares, so 2 squares times variance of x. So 8.08. Number 10. So now we have the uniform distribution. It's very much like the dice. So expectation, so 1 times the 1 over 6, 2 times the 1 over 6, 3 times the 1 over 6. So we have every term has 1 over 6. So 1, 2, 3, 4, 5, 6. 6, 6, 6, 7, 7, 7, 21. 3.5. Show that, 7 over 2. And variance is 1 over 6, 1, 4, 9, 16, 25, 36. So for t, this is 25, 50, 91. Minus squares. This was I think something for t, 50, 91 minus squares of the expectation. So expectation is 7 over 2, 6, 21 squares. So 36, 54 minus 36, 441, then 36, 105, then 3, 35 over 12. So expectation of this transformed data is it affects everything. So 2 ex minus 1, so 7 minus 1, which is 6. And variance, we get effect of the squares of the a. So 4 times 35 over 12, 35 over 3. Oh, find the value of e to the power of x. Oh, I don't know very much because this is not linear transformation. So let's just make it like this. I think it's not something, but we can compose the table very easily, like e to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5, 6, and 1 over 6, 1 over 6, 1 over 6, 1 over 6. This is x, this is px. Now we have table like this. So 1 over 6 times 2, 4, 8, 16, 32, 64. So now 7, 80, 90, 36, 126, so 21. And number 16. Random variable y is defined as it is, like this. Then y is 1.1. So ey is 3ex minus 1. 2.1, 0.7. So we know e expectation of x is 0.7. And when we add them together, a plus b should be 0.6. And negative 0.1 times a plus 2b should be 0.7. So a plus 2b should be 0.8. So therefore, b equals 0.2, a equals 0.4. Calculation expectation of x squared and variance ab. So 1014. A is 0.4, b is 0.2. So expectation 1 times 0.1, 0 times 0.3, 1 times 0.1, 4 times 0.2. So 0.5, 1.3. This is 1.3, and variance is we need to subtract the squares of 0.7. So 1.3 minus 0.7 squares, 1.3 minus 0.49, 0.81. So write down the value of variance of y. So variance of y is 9 times 0.81. 9, 7.29. So find probability x is larger than x plus y plus 2. So y is 3x minus 1. So 3x minus 1 plus 2x. So 2x is larger than negative 1. So x is larger than 0.5. Negative 0.5, right? So we can, oh no, sorry, not that one. So we can tell this is this one, 0.3 plus 0.4 plus 0.2, which is 1 minus 0.1, 0.9. Number 17, we have like this, random variable y defines as it is. Ey is negative 0.98. Y is larger than negative 1, is 0.4. Okay, 3 simultaneous equation A, B, C. So 2A plus 2B plus C should be 1. And EY, EY is 1 over 5, 2 over 5 minus 3 over 5, EX equals to negative 0.98. So this is 0.4. So 1,38 becomes 3 over 5 E of x. So times 5 over 3. 2.3. So negative 2a plus 2a plus 3b plus 4c should be 2.3. So 3b plus 4c, 2.3. And py is larger than negative 1, 2 minus 3x over 5 is larger than or equal to negative 1. Negative 5, 7, x is smaller than 7 over 3, which is 2 point something. So here, so when we add them together, 2a plus b equals negative 0.4. So this is what we know. So let's solve this out. Since we have 3 unknown variables and 3 equations, so we will find the answers. We can solve it out. So here, 1, 2, 3. Let me subtract 1 minus 3. So b plus c equals 0.6. b plus c equals 0.6. 3b plus 3c equals 1.8. Then now I calculated with 3b plus 4c, 2.3. Therefore, c equals 0.3. 0.5. C is 0.5. Then b equals 0.1. Then a equals 0.1. So, but this is not correct because it doesn't work. Let me do it again. B plus C equals 0.6. 3B, 3C. C equals 0.5. B equals 0.1. 0.15. A equals 0.15. Yep. Then it makes sense. So, C, probability of negative 2x. 10y is 2, 6x. So 4x is larger than 4. So this one, x is larger than 1. Means a plus b plus c here. So 0.15, 0.1 plus 0.5, 0.75. Number challenges. N be the positive integers, I suppose, like this. Show that. Okay. Variance. So let's try to do that. So 1, 2, n, 1 over 1, 1 over 2, 1 over n. So expectation, this is x and this is probability of x. So when we add them together, the product of x and px is 1 plus 1 plus 1. One to n discrete random variable. So when I add them together, no, sorry. I made a mistake. This is not 1 over I. This is 1 over n. So 1 over n, 1 over n, 1 over n. So the expectation is 1 over n plus 2 over n plus n over n, which means 1 over n plus 1 plus 2 plus n, 1 over n times n plus 1 over 2. That's why like this. So now if we have squares, 1 over n, 2 squared of n squared of n, 1 over n times n plus 1, 2n plus 1 over 6. I'm calculating x squares of expectation of x squares. So n plus 1, 2n plus 1 over 6. So the variance is n plus 1, 2n plus 1 over 6 minus squares of n plus 1 over 2. So let's make it 12. 12 and n plus 1 is common. So now we have 2n plus 1 minus 3 and plus 1. So for n plus 2 minus 3 and minus 3. So n minus 1. So 12 on the denominator, numerator n plus 1 and n minus 1. That's it.